Hello, so my name is Karthik Kumar Pandya. Today I am demonstrating my demo 0 for the basic microprocessors. In this video, I will gonna demonstrate how this microprocessors subtracts the value 8 and the 3 using registers, the ALU and the memory, and I will also explain what bits and registers are and why they are important. This machine is a digital machine, digital system we can say. Digital systems work using discrete values, meaning zeros and ones, instead of continuous signals like analog systems. We can see this clearly because all data in this circuit is represented using binary values and such as a 4-bit number that we can see here. A bit is the smallest unit of a data in a computer. A bit can only be either 0 or a 1. In this microprocessor, data is grouped into sets of 4 bytes, which makes this a 4-byte processor. So a register is a small and very fast storage location inside the processor. Registers temporarily hold values while the processor performs operations. They are important because accessing registers is much faster than accessing memory. So the this microprocessor contains several types of registers: the ROM registers, the RAM registers. So the ROM register stores fixed values that do not change. The RAM register stores values that can be modified during operation. The store B register temporarily stores one operand for the ALU, and the accumulator stores the final results of an arithmetic operation. All these registers that I have told you about, they all are in a parallel registers because all 4 bits are read and written at the same time. So right now we can see everything is 0. So for the computation I will go do read on 1, then we are doing 8 minus 3. So for that I will need ROM 0 to be 8. It's binary 1 0 0 0, and ROM 1 should be 3, so it will be 0 0 1 1. Now I have to, the address is connected directly to the ROM 0, but first I will need it to be a ROM 1, so I am connecting towards ROM 1. If I change it, now it's RAM 5. If I do, it's now on RAM 7. That's how it works. So now it's RAM 0, and we can see directly the path is going to directly be on a store B. That's all we need. So I am turning on the B. I am enabling the B, and I am putting clock up so it stores the value. So store B is storing the value right now. So I am turning it down. Enable B is 0. Now I'm jumping to the ROM 0. So address will connect it to ROM 0 now. So for that I'm putting it 0 0 0. So now it's connecting to ROM 0. ROM 0 is going to store B, but that what don't we need. So I am putting A or B. So now it's going to upwards, and now we can see here that's our answer 0101. It's 5, and that's we need it. So I am putting it on the accumulator and I am storing that value. So now we can see our final result is 0101. I am turning it everything down because we got our result, and turning in clock because it will not change. However, how much time I'll do this thing, but our value, our thing is, our result is 5 that we got. But if I do now I will gonna demonstrate a data bus conflict. If I put the accumulator out to be 0, it will going to show the error. That data bus now shows an error because more than one component is trying to drive the bus at the same time. A data bus is a set of wires and it can only carry one value at a time. So now I am putting clock should be 0, read should be 0, and I am putting the write on, and now I'm connecting uh, uh, so the I will write the result into the RAM location 6. So I'm putting the address 6 here, so you can see it's now on the address 6. So the RAM location 6 now stores the value 5. This completes, like we can see is here, so 5 5 5 so everything is, yeah. So this completes the subtraction of 8 minus 3 completely using the microprocessors. In this demo I have showed how registers store data, how the ALU performs arithmetic, and how values move through memory and the data bus. Thank you for watching my video.